Alright, so let's get on to redox. Now you've done a little bit of redox in grade 10, so this is unit 8. The first couple of units in your textbook, the last section is grade 12 work, so you need to use our notes, okay? So now redox reactions involve electron transfer. You know this, you've done this before. So for example, when magnesium burns in oxygen, the magnesium will give away its electrons to the oxygen, so that results in us getting magnesium 2 plus and oxygen 2 minus. Now what has happened is the magnesium has lost 2 electrons, so it has been oxidized, and the oxygen gains 2 electrons, so it is reduced. Okay, so our definitions of oxidation and reduction is the following. Oxidation is the loss of electrons and reduction is the gain. So you can learn this as oil. So oxidation is loss of electrons, reduction is gain. Okay, either way, it doesn't matter as long as you remember it, and that's what makes sense. Okay, now also once you finish this video on Teams, there is a video with a which says, I think it's called revision of reduction, or basic, it's redox reaction, revision of redox reaction. It's a really nice animation which shows you how this all works in a nice way that makes it easier for you to visualize, okay? But what you need to recognize, and you're going to write this in as we go along, the magnesium goes to magnesium oxide. That's oxidation, okay, because it lost 2 electrons. Oxygen goes to the magnesium oxide as well, but this is reduced because it gained 2 electrons, okay? So the oxidation and the reduction are half of what's happening. You can't have one reaction without the other. If one happens, the other happens. If something gives away electrons, something's got to take them. So if we look at it in general, if we look at oxidation half reactions, if we take substance X, whatever that might be, it's going to become X plus, and it's going to have, say, 1 electron. We're only doing 1 electron here. The thing about oxidation is the electrons are products, okay? For a reduction half reaction, now we have the substance, it takes electrons, all right, so it goes to Y minus in this case, okay? Now, this is very important. That electron that was given away is taken by the other thing, okay? You cannot have one without the other. Electrons can't exist on their own. So what that does is it gets us an overall reaction, because the electrons disappear, where X plus Y will give me X plus and Y minus. Now in this case, it's 1 electron, but of course it can be more than that, okay? Absolutely can be more than that. Now we have to add in an extra definition. So the magnesium was oxidized, the oxygen was reduced. Now, the reducing agent, that's what magnesium is a substance that is oxidized. It gives away its electrons, so it causes something else to be reduced. These are 3 different definitions, so you need to be careful, okay? If I ask for the reducing agent in terms of electrons, you have to tell me it's a substance that loses electrons. If I ask it in terms of oxidation numbers, which we're going to do in the next video, you have to tell me the oxidation number increases. If I don't specify, you can give me any. Alright, so that's quite simple. The oxidizing agent causes oxidation. How does it cause oxidation? Because it takes an electron. So it causes something to lose its electron. Okay? So that's straightforward. So it's the substance that's reduced, or it's the substance that gains electrons, or it's the substance whose oxidation number decreases. Okay? So if something is oxidized, it is the reducing agent. If something is reduced, it is the oxidizing agent. Straightforward. So let's look at an example. So what we have here is we have lead oxide and hydrogen becoming lead and water. The lead here going to here. That's reduction. The lead in the lead oxide actually gets reduced. The hydrogen is oxidized. Okay, so that's where oxidation happens. So what that means for us is because the PbO gets reduced, that makes the PbO my oxidizing agent. And because the H2 is oxidized, that makes it the reducing agent. All right. So now, before you carry on, and this should actually be page 277. Sorry, that is a mistake. Please do activity 1 on page 277. As usual, these the memos are on the communicator. Not on the communicator, I'm lying to you now. They are on the on Teams. Okay. Now, we get different types of redox reactions. So this is just really basic so you can see where redox is, and we use it in a lot of places. The first one is electrolytic reactions, which you've done lots of. You did this coming out your ears in grade 8, okay, where you look at the fact that we now use an electric current to cause electrons to get transferred, okay, so like the electrolysis of water. And what happens here is the oxidation half reaction is this. So the water gets oxidized. That creates oxygen, hydrogen, H plus, and 4 electrons. But at the same time, because water is very special, we know it can do all sorts of things, it also can get reduced. Now, before you go, am I going to remember those equations? You don't have to, okay? We're going to teach you how to find them. You're going to get a table, which is going to become your second best friend in chemistry, which is the redox table. And it's going to be really, really easy. Okay, so don't stress about it. You do not have to learn these. We're going to show you how to get them. Okay, so that's the first one. And we're going to spend a lot of time with these a little bit later. Synthesis reactions are reactions when 2 or more reactants bond with each other to form a more complicated substance. You've seen lots of those. Displacement reactions is one where we have, like if I put a zinc plate in copper sulfate, the copper will displace, the zinc will displace the copper, so the zinc kicks out the copper. So it's just where we have one ion, one substance replace another substance in the solution. Okay, so that's straightforward. And then of course there's decomposition reactions, and decomposition reactions are the opposite of synthesis reactions. So synthesis, we make complicated compounds. Decomposition, we take complicated compounds and make them simpler. All right, very, very simple, nice and easy. Okay, so the activity you need to look at is page 280. Once you've done that, we'll carry on with the next unit. Okay.